Today we're going to discuss the idea of an inscribed angle and the measure of an inscribed angle and the corresponding measure of an intercepted arc. That's kind of our goal for this session. The big difference between the angles and arcs we've been talking about before we were talking about a central angle, okay? And a central angle has its vertex. Oh, we can make that kind of funky. Don't need to do that. Okay. Has the vertex at the center of the circle. And we know the measure of the angle equals the measure of the arc. So that's kind of what we were doing before, okay? So I'm going to make that the radius of a circle for myself and then draw. Whoa, that's a triangle, not a circle. Awkward. All right, let's try again. There we go. There's a nice circle, okay? So before we had a circle like this and we had a central angle, and we knew that the measure of the angle was the same as the measure of the arc that it intercepted. And we called this arc and the arc being intercepted by the angle. Now what we're going to do is we're going to switch so that the vertex of the angle, instead of being at the center of the circle, is somewhere else on the circle at some other point. Now clearly, by stretching out that angle across the circle somewhere, we change the measure of the angle. It's no longer the same angle measure as it was before. In fact, if I look at it, it's a much smaller angle. The question is, how much smaller? And the answer to that little question is pretty simple. It is exactly half the measure. Now, the arc hasn't changed at all. The arc that it's intercepting is still the same arc. So now, instead of this measure of the angle being the same as the measure of the arc, now we have a situation where the measure of the inscribed angle is half the measure of its intercepted arc. So it's a new relationship. You have a couple fancy words in here. It talks about the arc is subtending the angle. Not really concerned about that word. I don't think that's going to be a big deal, but we should be aware of that. That's a word you could run up against now and then. So anyway, we see a difference, and again, the difference depends on where the vertex of the angle is. In fact, we're going to keep changing this up over the next few days, just so you're aware. We started with the vertex of the angle being at the center of the circle. Now we're moving the vertex of the angle to another point on the circle. We're going to talk about, well, what happens if it's somewhere inside but not at the center, or what if we move that vertex outside the circle? How's that going to change the relationship between the measure of the angle and the measure of the arc? And that's kind of what we're going to explore over the next few days. Okay? So kind of keep that in mind. And there's a theorem that actually formally says that the measure is 1/2. We aren't going to go into the proof of it. Again, it notes that the proof is on page 560 and it's part of exercise 37. Nothing that we're going to be really concerned with. Okay? But the measure of the angle is half the measure of the arc it intercepts. And again, the easiest way to tell what arc is being intercepted by this is to simply draw. I mean, we go, okay, there's my angle. Oh, what arc is being intercepted? There it is. Not hard to find. So using that theorem, let's find some measures. Now I said the measure of the angle is half the arc. So here I want to find the measure of angle T. Angle T is this angle right here. It does happen to have a diameter of the circle in there, but that really doesn't matter. Could be any two chords. And the measure of the arc is 48, so the measure of the angle has to be half that, so 24 degrees. We can also work this relationship backwards. Here I have this angle is 50 degrees. And I want to know what the measure of this arc that it's intercepting is. Well, if the angle is half the arc, that means the arc is double the angle. So double 50 is 100 degrees. That was a 50, right? Yep, okay. right? So we're talking about that one. So a double half relationship, you just have to remember the arc is the bigger one, the angle is smaller, because again, the angle got smaller. The arc and the angle were the same when the vertex was at the center of the circle, right? So as a matter of fact, if I were to do this angle, RPS, that angle would have to be 48 degrees, just the same as the measure of the arc, because that is a central angle instead of an inscribed angle. So keep that in mind. Central angle, inscribed angle are going to have different relationships. Your turn. Find the measure of arc RS. Just to help you a little bit, I'm going to highlight that for you. Mark arc RS. Arc RS, that's hard to say. Arc RS is right there. And just to give you a hint here, there's my angle that we're measuring. We know that angle U. So you go ahead and find the measure of that arc. Now, if I go back and look at that previous problem, I want you to notice something. That arc, or angle U, is intersecting arc RS. So is angle T. If I look at angle T here, both angle U and angle T are intercepting exactly the same arc. Now that arc measure is going to be exactly the same because it's the same arc, which means the angles have to be congruent, doesn't it? And that's what our next theorem says. If two inscribed angles of a circle intercept the same arc, then the angles must be congruent. And we can see that pretty easily, actually. Again, I'm going to try to draw a circle here. Maybe. We'll see. There's a radius. Draw a circle with that radius. And I'm going to inscribe an angle into this. So let's go ahead and we'll do one line there and one there. Okay? And that's intercepting some arc of my circle. And really the only reason I needed this radius here was for this, so I could note where the center of the circle is. We can get rid of that for now. Okay? And I know that if this arc is, say, 40 degrees, and this angle must be 20 degrees. But it doesn't really matter. I'm going to leave these 2 points fixed. Okay? It really doesn't matter where the vertex of this angle is, so long as it's on the circle. No matter where I put it on the circle, it still has to be 20 degrees, right? As long as it's not between. I guess what we can't do is we can't put the angle there. Whoops. Try that again. If I put the vertex there, oh, what's the measure of that angle be? That's an interesting question. I know that this arc is 40 degrees, but now this angle, 40 degree arc here, isn't the arc being intercepted. The arc being intercepted is the rest of my circle, isn't it? So if this is 40, that makes the rest of this arc 320 degrees, which means this angle has to be half of 320 or 160 degrees. Ah. So the theorem still holds. So pretty simple application here. Gosh, measure angle E is 75. E intercepts this arc from G to H, which we now know must be 150. So what's the measure of angle F have to be? Well, gosh, angle F intercepts exactly the same arc as angle E does, so it must have exactly the same measure, 75 degrees. And here are a few more to try. First one, find the measure of the red angle or the red arc. Here, the angle is red. It's intercepting arc from here to here of 90 degrees, so the angle. Now, again, think logically. We're doing a double half relationship. What if we go the wrong way? What if we accidentally doubled the angle? Well, that would mean that I come up with a measure for that angle of 180 degrees. But I look at that picture and say, that's impossible. That's a straight angle. This is not a straight angle. There's no way that angle's 180. What is it? Oh, I went the wrong way. It has to be 45 degrees. You try it for 38. Remember, you make a little sense. Finally, number 3, the red angle here has vertex at x. I know that angle y intercepts this arc from z to w, and that angle has a measure of 72, making this 144. X also intercepts at 144, so it must be the same as y, or also 72 degrees. And that's really what we're doing with inscribed angles today. We're just looking at finding their measures. All right, that's it. We'll see you in class.